So our learning goal today, I can identify the independent and dependent variables of a function. So we're still working with functions. And we're going to find out what do we mean by independent and dependent variables. And then I can write an equation in function notation. It's kind of like a special way of being able to identify that it's a function and writing it in function notation. So every function has an independent variable. Every function has an independent variable, usually represented by x. Now, y does not take over that role. I'm not saying usually by x and well, maybe sometimes it's y. No, what I mean by that is, if it's not x that we're working with, we're not working with x's and y's, maybe in the function they're calling them a's and b's. Maybe they're calling them m's and n's, okay? But typically, you know, in algebra we've noticed that they use x a lot, right? And in an ordered pair, the first number of that ordered pair is an x value. So that x value is an independent variable. And then every function also has a dependent variable. Usually represented by y. And we're going to say the dependent variable will always depend, part of the word, the dependent variable will always depend on the independent variable. So let's think of, you know, like situations in your life as a teenager. Who do you depend on? Anybody that you're depending on, or are you all independent? You still depending on parents? So in other words, they or whoever that you are living with really kind of make the rules, don't they? They kind of control your life to a certain degree. You might have certain freedoms, yes, but whoever it is that is in charge of you, they're the ones who are controlling. They're saying, you know what you do, it depends on what I say. Sometimes they get to just have that say. So when we think about situations even in life, there are things that we're independent of, there's things that we're dependent upon, and something is in control. So that's what we're going to be thinking about with our situations where we are identifying independent and dependent variables. Who's in control? What's in control? What's making the other thing happen? Okay, so I remember when I was a teenager growing up, if I had my way, I would have just gone out whenever I wanted, stayed out as late as I wanted, taken, you know, the parents' car. I didn't have my own, taken my parents' car whenever I wanted, but do you think that's how it was? No. So what I wanted to do, I got to voice it, but that was dependent upon what my parents said I could do. So they got to say, no, you will go out tonight, but you will be in at, let's say, 11 o'clock. So what they said controlled the situation. What I got to do depended upon what they said. Okay, so there's always this kind of, like, in these situations, we always have to think about what's going to be in control. So we're on page 180 of your book. So I want to make sure to that, just so we have the visual of what we're talking about here. Because there should be an example problem above, and like I'm guessing probably example 2. So we are kind of not quite halfway down the page below the example 2, where the directions tell us to identify the independent and dependent variables in each situation. So it's kind of like there's two things probably going on, and we got to pick out which one is going to control the other. So we got this company that charges $10 per hour to rent a jackhammer. So what are the kind of like things that can change in that problem? Is what they're going to charge per hour going to change? Does it say $10 an hour when you feel like paying that? No, that's not going to change, is it? They're charging $10 an hour for you to rent the jackhammer. What can change, though? What can change? How much it costs altogether? Yeah. How much it costs altogether? So the total amount that you're going to have to pay to rent this jackhammer. That's one thing that could change. And then what's another thing that could change in this situation? What else is going on? And you're going to rent a jackhammer for $10 an hour. What did you say, Samuel? Number of hours. Don't you get to decide how many hours you want to rent it for? Okay. So it kind of sounds like we got two things going on here. We've got the number of hours that we're going to rent it for, and then we got the total cost, how much it's going to cost altogether. Which one would control the other? Would the total cost control the number of hours you're going to rent it? Or would the number of hours you're going to rent it control the total cost? The number of hours. So the total cost is being dependent upon, you know, what time do I got to come home? That dependent upon what my parents said. The total cost depends on the number of hours. One thing will depend on the other. One thing will control the other. So the number of hours controls, so that makes the total cost dependent upon it. So our dependent variable in this situation, oh, I think I was meaning to write something else there, I bet. Huh? Nope, I didn't. Okay. So our dependent variable is what? Is it the number of hours or the total cost? Dependent. Total cost. And the independent is number of hours. Kind of think of it like this. Independent means you get to choose. So in this case, you get to choose how many hours you were going to rent the jackhammer for. Okay, anybody have any questions on that one? So in some problems of your homework, you have to pick out what is the independent variable and what's the dependent variable. And by writing maybe a sentence like this, the total cost depends on the number of hours, that helps you be able to then say, oh, well, that means this is the dependent and this is the independent. And notice what I put off to the side here. Remember, dependents are going to be y's, independents are going to be x's. So if we had to write an equation for this or an expression, whichever, we would be able to do it. But we're not practicing that right now. Okay, I want you to decide what are the two unknowns in this next one. Apples cost 99 cents per pound.
Total cost and number of pounds.
You think, class, do you agree with it? This is the total amount, the total cost. That's something that could change. And then he said the number of pounds that you buy of apples can change, right? Okay. So which one depends on which, do you think?
And the total cost depends on the number of pounds.
The total cost, how much you're going to pay altogether, depends on the number of pounds that you purchase. No abbreviating going on here, no text message language going on here, right off the words. Okay? So which one's the dependent variable? Which one would be kind of like taking the place of the y's when we have to start setting up equations?
Total cost.
The total cost, yeah. The total cost is going to take, the y could take its place. And the independent variable, what could x take the place of? Number of pounds. So when we set up equations, we have to be able to do this first. We have to be able to make a decision about what should represent what in the equation. You can't just be random about it. Just throw the numbers that you see in the problem together with some x's and some y's and assume it's just going to work out. You have to have a strategy. And this is helping us strategize to be able to set up our own equations well. Anybody have any questions on either of these before we go into function notation, our other learning goal? I can write an equation in function notation. Okay, then let's go down to that, our next arrow here, our learning goal of a function notation. So we are going to fill in the blanks here. We're going to say what variable is a function of the other variable. So in other words, think of it function as what depends upon something else. What's the result of? Because something else got to be in control. So when we talk about this, we're going to start this one with the dependent variable. This is often how they'll state it. This is math language now. So when they're stating it in math language, you're going to understand what they're saying. The dependent variable is a function of the independent variable. How you do in algebra depends upon, it's a function of how well I teach you. Or maybe that you even have a teacher to teach you. So the dependent variable is a function of, it is the result of the independent variable, the thing that is in control. So when we talk about then dependent variables, what did we say the dependent variable is usually going to be? The x's or the y's? Dependent variable. The y. Y is a function of x. X is in control. And when we talk about it, putting it in, so when we replacing these words, I'm going to go y is a function of, this is what they're going to say, f, this is the is a function of, that's the f part right there. So when you see that f, and then right behind it in parentheses dx, this is how this reads, y is a function of x. And in reality, maybe the is the equals, and the a function of is the f. Okay? So y is a function of x. That's what that is actually saying there. Okay? So in function notation, here's how we write it. The f of x, you know, that f of x right there, that y is set equal to, it replaces that y. So it goes in place of the y. So instead of our equation maybe saying y equals something, we're going to have f of x equals something. It is saying, we have, when you see that, it is telling you, you know what, we got a function here, and x is the independent variable, and here's what you're going to do to x on the other side to get the result, to get the dependent variable. So y just takes the place of it. So here's what I want you to do in your brain right now. I want you to know that those two are interchangeable. They take each other's place. If you see a y, it can be replaced with f of x. If you see an f of x, it can be replaced with a y. They mean the same thing. Okay? Adam?
So can I just put like arrows to show?
No. You can rewrite it.
I know, but like
Oh, like here on this?
on replaces, yeah.
So just, how about just do like this, f of x and y. And you could go like this. Yes, they kind of take each other's place. They are the same thing. I thought you meant like for your work. You wanted something for your notes, right? Okay, let's go to the back side then, and we're going to practice picking out the independent variable, the dependent variable, being able to write like a function rule. In other words, an expression that would help us get it, set it equal to y to make it into an equation, and then we're going to write it in function notation. So we're actually on page 181, it looks like, 3A. Stephen buys lettuce that cost $1.69. What's LB mean? A pound, okay. What depends on what here? Well, we got to decide what the two things are that are unknown. What are the unknowns in this? Stephen's buying lettuce. Seth, what do you think? Steve buys lettuce and it costs $1.69 a pound. What are the things that can change? How many pounds you get? Okay. So the number of pounds Stephen buys of lettuce. And what's the other thing that can change in this? Total cost again. Yeah, it kind of sounds like a lot of our other ones here. So which one depends on which?
Total cost depends on the real cost.
Okay, so the total cost, how much it's going to cost Stephen altogether, depends.
So if it shows that symbol, the LBS, like, can we just write it like that then? It shows it like that instead of writing
Yes.
it down?
Yes, you may. Total cost depends on number of pounds, and I think this is the question Adam was just asking. Since it wasn't written as P-O-U-N-D-S in this, can we write it like this? Yes, you can. That's how they wrote it, and you may write it like that. Okay, so that makes the dependent variable y, which one? Which of these two is the dependent then?
Total cost.
Total cost. So the y's are going to represent the total cost in our work. And the independent variable, the x's, are going to represent the what? Number of pounds. Okay. Okay. We have to dig back a ways here to remember what a function rule is. Anybody remember off the top of their head what a function rule is? What do I mean by what is the function rule for this one? Is you got it on something that, go ahead.
Is a type of relation where each.
No, okay, you can stop Adam. I'm just going to stop you only because you're giving me the definition for function. I want to know what we mean by function rule. Okay, they kind of mean separate things. A function rule means this. What do you have to do to the x? What do you have to do to get the answer to this problem? So what do we have to do? He's buying lettuce that costs $1.69 a pound. So the rule would be take $1.69 times the number of pounds. There's our rule. Take $1.69 times the number of pounds. Stephen buys lettuce that costs $1.69 a pound. That's the rule part. And then to write the equation, we set y equal to that. Or in other words, we say to get the total cost y, you will take $1.69 and multiply it by x, the number of pounds. So you always, in a function, you always do something to x to get the y. So the function rule is, what are you doing to x? And then you can set that equal to y. And then when you write it in function notation, if they say they want you to write this in function notation, anybody think they know what we could do to put this in function notation? Considering what I said on the front side, on the bottom there? Preston, any idea? How about you look at least? Maisie? Holly? Okay. Well, I'm not going to sit here and let other people keep answering for you guys. I want you to engage and try too. Blake, you got it? No? Seth? Maisie? Try. Andrea? Oh yeah, Adam. Save them.
The function notation fx replaces y.
So f of x will replace y,
That or y can replace xf.
or f of x can, or y can replace f of x. Well, since we have to write it in function notation, we need the f of x to replace the y. So f of x will replace the y in our equation. The function rule will stay the same. Now we have function notation. This tells us we have the function of x is, take $1.69 times it. And the result will be, what did we say? Remember, f of x is replacing y, so f of x will really get us what? What would it really get us? If it replaced y, what is that going to get us after we take 1.69 times x? Total cost, yeah. It's still going to get us the total cost, it's just written a different way.
So it would still just be 1.69.
So let's replace that with something. Let's just use something. Anybody think they can do some multiplying there on their head here? What if Stephen buys 2 pounds of lettuce? What's f of x going to be? Okay, resort to your calculators. 3 what?
38.
Yeah, $3.38. So f of x is going to be $3.38. The total cost is going to be $3.38. So f of x is standing in for y, the total cost, and we can get it by just taking 1.69 times the number of pounds. Okay, let's do one more here. We We have this amusement park that charges a $6 parking fee plus $29.99 per person. Okay, what are the two unknowns in this one?
Parking fee.
No, they already told us how much they're gonna charge. How much are they gonna charge? How many people are coming? Okay, yeah, how many people are you gonna have? What's another thing that we don't know then? So, number of people, that's not known, you get to decide. How many people are you gonna take to the amusement park? Number of hours, okay, is there anything in here that says per hour?
No.
No, so you think the number of hours is gonna play a role? No?
The parking. No. Park charges. $6.
You charge $6 to park the car and then $29.99 for every person that comes through the gate of this amusement park. So after we know how many people are going,
How much will this be on the fee? Like no. Okay, yeah, I don't know.
we're getting there. How many cars? Okay, so does it say anything about so much per car anywhere?
Just the parking fee.
Sydney?
The fee to get in the amusement park?
So the fee to get in the amusement park, so you mean like the total fee?
Yeah.
Yeah, the total fee or the total cost to get in. So what's gonna depend on what then? Is it the total fee, that total cost? Gonna depend on how many people, or is the number of people you take in gonna depend on the total cost?
Number of people.
Yeah, number of people is gonna depend on the total cost?
The total fee.
Cost
Yeah, I think the people are controlling the situation here. How many people are you gonna take? You know, if you don't wanna spend a ton of money, aren't you gonna kinda keep your, an invitation list down a little bit? Instead of inviting the whole school to go to the amusement park with you and say it's on you? Total cost depends on number of people. You better pick how many people you're gonna take if you're buying, because that's gonna control the situation. It's gonna determine how much money you're gonna have to spend altogether. So what's the dependent variable? Total cost. Independent, number of people. Okay, now we gotta come up with a function rule. In other words, what do we do? What are we gonna do that we're eventually gonna set equal to y? What do we have to do to figure out what that total cost would be? Go ahead, write something down on your paper with your pencil. What do you think the function rule is? I want you to put a line here and I want you to put it right there. What do you think the function rule is? What do you have to do to determine how much money this is gonna cost you, which will be what when we set y equal to it? Okay, who wants to offer up their function rule? What do you think would be a good function rule for this one? So the function rule always has the x in it. What do you have on your paper? Holly, what do you got on your paper? Nothing. Oh, darn. Okay, Andrea, what do you have on your paper? Nothing. Maisie.
I have 29.99x.
That's it? Okay. Anybody else have anything else besides 29%?
Y equals.
No, we're just doing the function rule part, we're not saying equal to y yet. Is that all it's gonna cost, is $29.99 per person?
Plus
What's that $6 parking fee, yeah? Plus that $6 parking fee. Now we can set that equal to y and say the total cost will be 29.99x plus 6. And by the way, the 6 and the 29.99x, those two could trade places. The 6 can't be in front of the x. I mean, it can't be 6x, but it can be 6 plus, you can start with the parking fee, 6 plus 29.99x, and have it set equal to y. Okay, now you write that in function notation, because you know how to. Write that in function notation. Pay really close attention in the directions of your homework when I ask you to write it in function notation. It has to be written f of x instead of y. F of x equals 29.99x plus 6. If they don't specify function notation, then you get to let the y stay there. But if they say function notation, there shouldn't be a y in your equation. There should be an f of x instead. Okay, any questions? It's important that we know how to set up these equations, and we can't just be, like haphazard about it. We can't just say, well, there's this and there's this and there's this, I'll just throw it all together and good enough. Because if that was what everybody did in everyday life, and they did that to you out at a restaurant and said, well, you know what, here's my equation for how much it's going to cost you for lunch today, and you order your typical, like what you would go in and order, and they say it's $79.38. Would you stand for that? Most likely you would respectfully say, I'm just having a sandwich and some chips in a pot. How can this be $79.38? And they'll be like, well, here's my equation. Here's what I did. I put this in, you ordered one sandwich and you ordered one chip and one pot, and this is what I got. And you want to be like, hopefully you'll be able to say, I don't think your equation is right. You kind of just threw some things together and you're overcharging me. You would be ready to stand up for yourself, I believe. Okay, let's go to homework. You know what?